Assalamu alaikum wa rahmatullahi wa barakatuh, friends. Welcome back to my channel. While repairing this Samsung microwave oven, I used my small voltage divider network and discharging circuit for high voltage capacitor, and I received a comment from my viewer. شكرا لك أستاذ الفاضل على معلومات القيمة وجعله في ميزان حسناتكم أستاذنا. ممكن مخططك بالتفريغ المكثفة ونحن شاكرين لك. My viewer saying that thank you dear teacher for this valuable information, and can you provide circuit diagram for this capacitor discharging circuit. This small and simple circuit, it provides us facility to discharge the capacitor, and also we can measure high voltage using our simple multimeter, because this multimeter it can measure up to 600 volt 700 volt, but using this assignment we can test high voltage with the same multimeter. This circuit in two portions. The first portion, that is 20 kilo ohm 2 watt resistance, and here I have two resistors, 2 kilo ohm 2 mega ohm. This wire, it will go to chassis, and this will go to high voltage capacitor. This is discharging circuit, and this is high voltage measurement circuit. Now we will measure it practically. This will go to high voltage capacitor, and we can also check high voltage transformer here. This will go to DVM high, DVM low. So we are using 2 mega and 2 kilo ohm resistance, so it is 1000 ratio. If you will provide 5000 volt here it will read 5 volts. This is capacitor discharging circuit, 20 kilo ohm, and here I have 2 kilo ohm resistance. Try to use fixed resistors, 2 kilo ohm, and from this point to this point I have 2 mega ohm, 1.994 mega ohm, that is 2 mega ohm. At this point we will connect common lead. Here we will connect positive lead. First we will measure high voltage, common to common, high to red lead. This is in voltage mode. And now I will plug in microwave. I will connect one lead of this small tool to the chassis, black lead to the chassis, and I will start any cooking profile. Now I can measure voltage, high voltage. I can see it is showing 1.56 volt. So this capacitor is charged at 1600 volts negative. If I will measure directly with this multimeter it will damage, but now it is showing the capacitor charging voltage. Same way, if I want to test AC voltage, I will select multimeter to AC. Take care, we need to connect in AC range. One lead is connected to ground, and now I will select cooking profile, and I will connect to AC terminal of the capacitor. It is 1.99 volt. That means the transformer is providing 1.99. It is 1.99 kilovolt. The multimeter showing here 1.99 volt, that is 1.99 kilovolt, 2 kilovolt. So transformer is providing 2 kilovolt. Set multimeter to DC. Connect to capacitor. At that point where the diode is connected, select cooking profile. It is showing 1.3 kilovolts, that are DC voltage, because this time the magnetron is connected and the system is loaded. So we are taking 1.6 volt DC because output side of this capacitor is connected to magnetron here. So voltage across this capacitor, DC voltage, that are approximately 1600 volt right now. But transformer is providing 2 kilovolt. It is voltage doubler circuit. Because this transformer, one end is connected to chassis, the second end is connected to high voltage capacitor. When we will measure DC voltage, we will check at this point, which is connected to magnetron, and here 1.9 kilovolt, 2000 volt here. Normally 1800 volt to 2200 volt must be there. So we can test these voltage using this assignment. So here we can use 2 mega ohm, half watt or 1 watt resistor, and here half watt or 1 watt resistor. 20 kilo ohm 2 watt. How we will make connections? This is the common point here. So this end we will connect to chassis. We can use any binding post, black color, to identify that it is common chassis, and here multimeter low. This is 20 kilo ohm resistor that is connected between these two terminals, and we must mark that this is discharging point. And here is 2 kilo ohm resistor, and this is 2 mega ohm. I am using 1 mega, 1 mega. 2 mega ohm resistor here. Between these 2 points, 2 kilo, 2 mega, 20k. Common, positive, positive. When we are measuring voltage, we will connect here. When we are discharging the capacitor, we will use this one. To discharge this capacitor, we can connect one lead to the chassis here, and we will connect to the one end, the end that is connected to transformer, that is normally connected to ground through this transformer winding. So for safety we can discharge it. The most important point, that is the other side of this capacitor, connect it here, and for more safety we can connect to both terminals. For extra level of safety, use any long nose plier having good insulation. Its grip insulation must be safe. Inspect it carefully, and then we will connect between both terminals of the capacitor. That is extra level of safety. Normally when the unit is working good, at that time this capacitor discharges automatically through its magnetron and it becomes 0. But the problem, when the magnetron is dead, at that time this capacitor will hold the charge. Let's see it practically. When we turn it on, we can see this time the voltage are 2.6 kilovolt, then 1.4 kilovolt, it is 1.4 volt. When I will turn it off, this capacitor is now discharging. Now it is 0. This time it is safe. We can touch it, but We don't know when the magnetron is dead or we have any disconnection, any problem. Maybe the capacitor will hold the charge. If it is holding charge and we will touch it, at that time it will make problem. So for safety we can test voltage and we can discharge it. And we must verify that there is no voltage available at this capacitor. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.